Good morning, everyone, or good afternoon. Welcome. Thanks so much for joining. I wonder how many of you are, like we are, a little sleep deprived this morning after last night's Aurora, which I hope many of you managed to see. It was quite spectacular. We are going to talk primarily today, however, about the moon. We have a number of things coming up over the next 12 to 18 months that are moon related. So the title of today's webinar is Extreme Moon, which is a rather marketing sort of term, I would say. But it has some meaning, and we'll go into what that is and what that might do in terms of creating interesting opportunities for you as photographers of the moon. So let me just jump into a slide. Oh, that was from last night. I'm guessing a lot of you saw this. I know my family back in the UK did and got some great photos just on their phones. It's quite spectacular. We drove a couple of hours north of here. So we're in Colorado. The skies were cloudy but clearing. But of course, the further north you go, in normal circumstances, the better your chances. Last night, it seemed to get everywhere, which was amazing. This is also last night's moon. And I think it qualifies under the banner of extreme moon. And I'm going to show you why that is. Here's another photo again from last night, and you might think, what's particularly interesting about that? And it occurred to me that one thing that sets this apart, obviously, seeing the aurora in lower latitudes is a wonderful and spectacular thing. But seeing the moon in the same frame as the aurora, as we're facing sort of roughly northwest here, is particularly interesting. So we're going to talk a little bit about why that is special. Thank you to everyone who submitted questions in advance. I've plucked a few of those out. There were some good ones in there that it always helps shape the material. So thank you for doing that. Thank you to Alice, who's downstairs operating the webinar behind the scenes, and will also take any of your questions that come in that I don't get to, or which she can answer offline. And in addition, we have another resource for all of the users, which I'd encourage you to check out, and that is here on the forum.photoephemeris.com. And this is a sort of forum bulletin board type site. You will need to register to post on it, but you can view some of it without being registered. When you register, the easiest way to do it is, if you're in the app here, there's a link at the top right, and if I click that, it'll tell you what to do. And there's a little invite code you'll need to type in, which is more sunshine. And you'll find a link to this in the iOS app as well. So please join at the forum. There's lots of interesting material there. You see Dave's photo of the aurora from last night, and there's a bunch of good eclipse photos. Last time we had a webinar was before the eclipse, so there's been a lot of stuff going on photographically, and it's been great to see you sharing some of those results here. We got a whole solar eclipse area here. So yeah, please do join us on the forum. We'd love to see you there. So let's just talk a little bit about the main topics I want to cover today. I've got a couple of little things to show you that have changed in the web app. Rob asked the question, is there a breakdown or a legend for the web timeline? So what the different entries on the timeline mean. So I'll show you what we've added to help with that. The main thing I'll jump into then is talking about the moon's declination and what that means for where it's going to appear in the sky, and what that means for photographic opportunities. That's the main thrust of today. And in that context, and the reason this is all bubbled up, I think, as an interesting topic to talk about, is that we are, in addition to being in the middle of the solar maximum, where we see all this auroral activity and flares and so forth, and major sunspot activity, we're also in 2024 and 25 at the major lunar standstill. So we'll talk about what that is. It's related to the declination of the moon, and we'll look at some scenarios about how you can understand the alignments in that time frame. And then I'll talk a little bit later on about upcoming lunar eclipses. There was a partial eclipse in September, and there was a total eclipse in next March in 2025. So we'll probably look at that total eclipse. And I will share a few thoughts on how to photograph those on my own experiences, and some tips that may be useful for you. So let's jump in. So here's the moon. This is last night. North is sort of off this way. We're looking roughly northwest, northwest, I would say here. This is up in Wyoming. Not a lot going on. Clear views to the north. Not much in the way of interesting foreground, unlike Dave's beautiful shot on the forum. But there is the moon. It looks sort of fairly bright, but that's really because of the exposure that was required to capture the aurora. I think this is probably 5 seconds or so at f4 ISO 1600, I think I was at. And so the moon is showing up pretty bright, but in fact, a well-exposed photograph of the moon, that's how it looked last night. So, you know, it's new a couple of days ago, I guess, and not much illumination. If you do a longer exposure, you pick up all of the earth shine coming off that face, and that's what's showing up as a sort of a brighter object here. But what's interesting about it is, as I alluded to earlier, is just how far north this thing is setting. So it's setting about there. This was at about 10 to 11 something last night. Not too late. It set at about 11:40. Maybe it was a little bit later. Maybe 11, after 11. I forget. And this is the location we drove to. So we live down here this is the middle of the US, just so you get your context. We live down in Boulder, which is down here, and it was pretty cloudy for much of the day yesterday. But as we drove north, skies cleared, and as you saw, we had beautiful clear skies up here last night. And we drove up to north of Cheyenne, cut out on this road towards this little town of Meriden, and found a tiny dirt road off to the left here. We were there for maybe 2 or 3 hours. 3 cars passed us, I think. And one of the reasons we went there was this is particularly dark skies. There's very little going on in the way of light pollution around here. Other areas like that are up here north of Laramie and Cheyenne. Obviously, you get some light from Cheyenne, a little bit from these towns up here as well. But this was great. So it was lovely dark skies. But let's look at a couple of things here. We've got the timeline, and you can see there we have the moonset. Now, here's one of the things that's new. I'm hovering over the timeline here, and if you're in the web app.photoephemeris.com, you will see these new sort of hover over tips. So whenever you hover the mouse over a timeline event, it'll give you a quick description of what it is, and then some general photography tips. Obviously, there's a limit to how much you can say for these things, but hopefully this will begin to give you some, make it easier to understand everything you're looking at. There's a lot that appears in this timeline nowadays, and some of it may not be immediately obvious. So I think it was high time to add some content in here. And as we go, you'll see that there are different tips. So this is an interesting one. For example, this was 2 or 3 days after new moon, and so while the moon is, I think, in its first quarter or thereabouts, we show these crescent moon best visibility times, and you'll see beneath there, just below my pink mouse there, it says A 11.45%. So that's showing you that the moon is 11.45% illuminated at this time. And the A letter indicates that it's easily visible. So the grade here tells you if it's a new moon, how easily will it be for you to see it and observe it in the sky, and it gives you what it thinks is the best time. It's sort of a heuristic. It's not, there's no super precise reasoning behind this, but it's sort of a rule of thumb that was developed by this astronomer Bernard Yallop out of the UK So this is called the Yallop scale. And it tells you when the best chance is of seeing it. And this becomes more significant just after new moon, when the skies are brighter and the moon is tracking closer to the sun. So you can explore these, see what the tips are. Hopefully that will be helpful in general for understanding what you're seeing on the timeline. Let me come forward one day. Well, let me just say one other comment. Here's moonset. And the azimuth of moonset is 309.29 degrees. That's this dark blue line up here. And moonrise, let's have a look, moonrise, 51.47 degrees. That is very close to the extreme northerly directions in which the moon will rise or set in this part of the world. And that is all to do with the lunar declination, and it's to do with the major lunar standstill. So if I come forward to today, one of the things you will see is here we are. There's a new event. This is available with the subscription plan, and it is the maximum lunar declination. It's the time at which the maximum declination is reached. So there's nothing inherently magical about that precise time. What is interesting about it is what it tells you around other lunar behavior. So moonrise, moonset, and moon transit. When those events happen in proximity to the maximum declination, you can sort of infer quite a lot of information from knowing that they're close to the declination. Let's look at what I wrote for the photography tips here. Look for alignment opportunities that arise only when the moon rises at its northerly limit, or sets at its northerly limit. At times near maximum declination, the moon will appear higher in the sky for northern hemisphere observers, which may provide improved seeing if you are looking to do a long focal length telephoto shot of the moon. The general principle is that there was a question. Let me find that question. Yes, so Rocco asked, would love any tips about planning around seeing and transparency issues. So one of the things when you're photographing any object in the sky is when it's low on the horizon, you have the light from the object to your eye or to your camera is passing through far more atmosphere than it is when it's high in the sky. It's very significantly more as it sinks through the atmosphere. So that's why we can almost look at the sun with the naked eye, very close to sunrise or sunset, but not when it's higher in the sky and the light is less filtered. So the same thing applies to the moon. So if you're looking for a moon high in the sky, looking for something around the time of maximum declination will, if you're in the northern hemisphere, will be good for that. And we'll have a look at why in a moment. So that's maximum declination. And you're also going to see these events here in the event list. So for example, let's look at May 2024, where we are now. We've got, there we are, maximum lunar declination. I give the declination value, that's 28.48 degrees. We'll talk about what those numbers are. There's two numbers to remember, 28.5, 18.5. Those are sort of the main things. And there you see, roughly a couple of weeks later, there is the minimum lunar declination of minus 28.4. So you see it's roughly the opposite sign of this. Let's click on that date, select, look at where the moon and the moon is rising and setting, way to the south, way to the south. So why is that? Let's click back over here and we'll have a look at this little diagram. Now, it's a little bit tricky to look at every possible scenario of how these things can line up. But let me just talk about some of the basics that hopefully will give you a good mental model for this. There's the sun, there's the Earth in blue, and the plane of the Earth's orbit around the sun is the ecliptic. That's the name for it. And the axis of the Earth's rotation is inclined at around 23 and a bit degrees to the ecliptic. So here in this diagram, this is just one scenario. You can say, okay, so the northern hemisphere, let's say this is north, this is south, is inclined away from the sun. So this is showing a scenario during the northern winter and the southern summer. There's the equator, that's there, and this angle between the equator and the ecliptic is this 23.4. If you read look on astronomical sites, you may see this referred to as the obliquity over the ecliptic. It varies a little bit, and you get something called nutation in obliquity. All these crazy terms that can take a long time to digest what they mean. I found having worked on this stuff for some years. You go, okay, well, I've implemented the algorithm, but what does it really mean, and how do you intuit that? Anyway, 23 degrees roughly, moves a little bit over time. Photophemis and similar apps calculate all this stuff for you, so you don't need to worry about it too much. Here is the moon. I'm showing the moon being between the sun and the earth, but inclined to the ecliptic by about 5 and a bit degrees. So that's the normal orbital inclination. And so during the roughly every month, we'll talk about what the roughly means. The moon is circling around this orbit, and its actual declination varies between, or its inclination varies across that month. So what does that mean? Is the declination then is calculated like this. So in this case, the moon is 28.5 degrees below this plane here. That's where the 28.5 comes from. So what it gives you as a rule of thumb is that when you're looking at this events list, you can very quickly eyeball a couple of things. You can say, okay, if the new moon is maximum declination is happening between new moon and first quarter moon, that means that this is the day when the moon will rise and set at its most northerly, this at its most southerly, and that is true whether you're in the northern hemisphere or the southern hemisphere. It makes no difference. If we find a month, let's have a look, for example, later in the year, December, the maximum lunar declination, 28.4 again, is very close proximity to full moon. So you can look at that and go, this is going to be a full moon that will rise in the north. So let's have a look. And indeed, there it is. Now, we've had tools in TP for a long time, like visual search, that let you put in azimuth ranges and find when the moon is going to rise in different and set in different directions or areas of the sky. But I think this gives you a slightly more intuitive understanding, gives you some shortcuts for quickly identifying when things are going to rise and set in different parts of the sky. So then let's look, we come over here. So there's a little article about this that you can find down here if you type in the help window. That should pop up in a moment. Thank you, Zendesk. It has not popped up. There it is. There we go. Okay. Let's have a look. It should be there. Lunar Declination. So you can find it just by typing in the little search window there. And this gives you a bit more of a technical overview of what we talked about. I've got a couple of diagrams in there that show different scenarios and how to find these events. And then if you really want to get into this, I'm not going to go in much more detail, but I will call out this. There's a very good article by NASA, and the link is here. This is the page here, and it's by Fred Espenak, who you may recall I mentioned in some of our Eclipse webinars, and it talks all about how these lunar cycles relate to eclipses. But one thing to be aware of is that there are 3 months associated with the moon. There is the normal one that we think of as from the moon phase, new moon to new moon, which is that long. Then there is from perigee to perigee. That's called the anomalistic month. I don't know why. And then there is from node to node, which is the draconic month. And that's what we're talking about with the declination. So that's basically, coming back to this little diagram, when the moon passes through 0, on its way up to a positive declination, that's that full cycle. And what's interesting is that they're all slightly different lengths, and that's why these things become hard to predict. And that's why, again, in May, this maximum declination is happening between new moon and first quarter moon, but by December, it's happening close to full moon. So the events list lets you scan for those things, look for the proximities you're interested in. So for example, let's see if we can find, just by looking at this, a first quarter moon. Might have to go into 2025 to see this. I'm looking for a quarter moon in proximity to maximum lunar declination. I think, there we go, March 2025. And there we are. This is I think this is the very highest value you're ever going to see for the maximum lunar declination. So this is the peak of what's called the major lunar standstill. So when I click there, I'm going to go to that location there. We've got northerly rise, northerly set. And if I go into the evening, go to the transit of the moon, at its most northerly, look how high in the sky that is, plus 76 degrees. And that is because the moon is at its northerly declination. So that could be a good chance for a quarter moon. Is a nice photographic object to look at. Half illuminated, you get lots of nice shadowing along the terminator, which is the line between the light and the dark. And you can pick up a lot of craters and so forth. So if you're looking for good seeing conditions, then high in the sky is good. So a quarter moon in proximity to maximum declination, great. Let's now go back to 2016. I'm just going to type in 2016, and we'll pull up the events list, and let's have a look in what we got there. Okay, there's a minimum lunar declination of minus 18.2. So you may recall earlier I said two numbers to keep in mind here when you're looking at these declinations: 28.5 and 18.5. The way to think about this, it's the moon's equivalent of the solstice. At the height of summer in the northern hemisphere, June, the sun is rising at its most northerly, and December 21st, it's rising at its most southerly. The moon has the same thing, but it does it multiple times a year, and the cycle of the maxima and the minima varies over a period of 18.5 years. And that's what is called the lunar standstills. So let's just have a look at a few little websites here. So this is on English Heritage's site for Stonehenge. Just read this through. Stonehenge is famous for its alignments with the sun, but did you know that the ancient monument may have also been carefully designed to align with the movements of the moon? 2024 is a special year as an astronomical phenomenon called the Major Lunar Standstill occurs. This rare celestial phenomenon, rare every 18 and a bit years, presents an opportunity to explore the connection between Stonehenge and the moon. So this explains a little bit about the alignment of the site, and when the southernmost moonrise at major standstill. So what they're saying is that this time of year, when the moon's declination is down at minus 28.5, that's sort of where in southern England, so we're talking what, 51, 52 degrees north, that's where the moon is going to rise. So that's one. Here's another one up in Scotland. We have Callanay Stone Circle. This is a very comprehensive report on excavations that they did, and you can find it quite easily from their main website. It's linked there, and it talks about their analysis of the site with respect to the lunar standstill and the alignment with these stones. So that's another example. Quite a few of these around the world. And then one closer to home, Chimney Rock. So Chimney Rock is in southwest Colorado, and here's a little image that shows you there's two rocks. There are so many rocks in the US called Chimney Rock. You have to be careful which one you search for when you find it. So this is, I think, Chimney Rock. This is called the Companion Rock, and there's a sort of little ridge. We'll look at the map in a moment, and the moon rises between these two around the times of the major lunar standstill. So there's a theory that was published back in the 80s here that the site, there's some buildings on the top of this mesa may have been built to sort of celebrate or honor this moonrise that seems to have some significance and you know, special quality to it. So I went there in 2015. This was, so that was around the time of the minor lunar standstill. So that's the plus 18.5, minus 18.5. So that is when the rises and sets are more moderate. They're less northerly, less southerly. But then at the major lunar standstill, when they become more extreme. And so this is one of these things that really you only get to see around for the next year, 18 months. It changes a little bit slowly around the maximum, but it's, you know, this next 12-month period is the main time. And I thought I'll be very clever. I will get out my app here with my theodolite, I think it was called, and I will record the exact position and the elevation angle. So there's the moon smack bang in the middle of the rocks, from in the middle of this structure here. And I will check the elevation angle, and I'll get the direction. Here's one of the regular reminders to never trust your phone's compass unless you very carefully calibrated it in the figure of 8, because this is about 14 degrees wrong. That's not the app's fault. That is the compass in phones gets knocked off very easily. So how do I know that that was the case? Well, let's work through this as an example. So first of all, I'm going to pull up Chimney Rock. Chimney Rock. Oh no, that's my search. I actually have it saved over here. Otherwise, I'll get a gazillion things called Chimney Rock. There it is, Chimney Rock. There it is. And I'm going to go to hybrid map. There it is. Now, so the little access road, this is down in southern Colorado. There's Pagosa Springs. Just there's Denver. That's where we were that's last night's Aurora. There's Denver, Boulder. You drive down to Pagosa Springs, a few miles out of town, and you can come and visit Chimney Rock. So we'll zoom in on that. And you see there's sort of this ridge line that's pointed north. It sort of runs from the southwest to the northeast. Let's zoom in a little bit more. There's a trail to get to the top of it. There's the trail, and there are the structures that were built, or some of them. That's the main structure. So that's where I took my photograph from. And when I checked the bearing, I did a little bit of research on it, thinking, is that correct? Because it seems too far south. And one way you can check the bearing is you can say, well, look, we know that I have some other photos that show this wall to the left here. There's the circle. If you come in here, zoom in, put geodetics on. Oh, that was one more thing I was going to show you, is that you can now hide the sightline altogether with that button and drop that there. We know that's roughly the direction. And you go, well, that's 64 degrees, but that doesn't make a lot of sense because it's off to the left of the wall. There's another shot I have that shows it more clearly. So the true bearing, I then found they published the whole history of this, and here's the map. You zoom in so you can see it. So there's the Great Kiva, the stone circles, the site I was showing you. This is actually the area from which they think it was primarily observed. There's the companion, there's Chimney Rock itself, and we're looking through the little gap between these two. They all seem to flatten out because of the distance. Scale is 500 meters, so that's 1,500 feet, roughly from there to there, I'm guessing. And this was from where this photograph was taken. So this is back in the 80s between the rocks. And then there's this very nice little diagram that says, okay, so the correct azimuth, this would have been surveyed on site, so I think we can trust it, is 56 degrees. So if we go back here, I'll turn that off. I'll put this back up here, so that's roughly the site. And I put this to 56 degrees. There it is, more or less, 56 degrees. And then let's come to today. And if we go to, for example, let's go to October's full moon. So there's October's full moon. And you see it rises off to the south. So you think, okay, that's not quite going to do it. But if we look in the list again, whereas declination is to the south, max declination is 4 days later. So we're a little bit early for that full moon. But if we go to December's full moon, there it is. That's the one I mentioned before. It's very in close proximity to the maximum lunar declination. And there it is. It's come forward and we'll bring it up to about +4 degrees. That at least that part was correct in my 2015 photograph. So I'm just advancing with the cursor key on the timeline. We're about 3 or 4 degrees. And there it is. Lines up exactly. So that is the manifestation of the major lunar standstill. And what does that mean for you as photographers? Well, a couple of things. You may be able to visit some of these sites. I don't think you'll be able to visit this site. It closes in October, unfortunately. And at the moment, there is no provision for access around the December full moon, which is sort of the main event. There are other moons that rise that far north, obviously, but they're not always the full moon. But there may be other locations that you can find where you know there's a viewpoint from the south to looking farther northeast than you normally do, or setting farther northwest, that you can get some unique alignments that will only occur really around the next 1 or 2 years. And you can get different moons at those extreme positions. Same goes for southerly alignments as well. So I wanted to make sure that you had an understanding and the tools together to say, okay, minimum lunar declination, 28.5, that's good. That's one of the extremes. We're at the major lunar standstill. When you're looking in other years, you'll see these values decrease in absolute value through to the minor lunar standstill in about 9 or so years' time. One more thing that can help with this in this article, there are a couple of ways to do it. You might say, well, if let's say I wanted to use visual search just to find these times, what are the azimuths I should use for the direction? Well, you can look at this scenario and you can say, well, it's around 56 degrees when it's 4 degrees above the horizon, and moonrise is at around 53 degrees here. As a little additional aid, there's a table here in this article, which is the rising azimuth versus the declination. So I've put in 4 columns. So there's the positive 28.5 degrees. If your latitude, where you're observing from, so let's say you were in the northeast of England, where I grew up, then that's the declination of the moonrise. So that's the azimuth of the moonrise. And then it's further south. So 33.7 is quite a long way north. It's only 30 degrees from true north. And then when you get to the minor lunar standstill, that's 56 degrees is further south, and that's as far north as it will rise. And then similarly for the southerly, the minimum declinations as well. So there's a lot of numbers. Sorry for that, but I hope this sort of gives you a sense of the main points I wanted to convey were we're at the major lunar standstill. The moon will rise and set at its extremes of both north and south. that will create some unique alignment opportunities. So when you're wanting the moon rising behind a building, a structure, a mountain, whatever it might be, you've got more latitude in those rising and setting azimuths than you have at any other time in the next 18 years. In addition, during the transit, so that's when the moon is, let's have a look here. Let's see if I can find the transit of the moon. Where did it go? Let's have a look. Transit, moon, transit. There we are. There's moon's transit. The transit of the moon, you can control for that being higher in the sky for better telephoto work, shooting upwards through the minimum atmosphere, so best seeing. Or in addition, I'll show you another example of this. You can get the moon lower in the sky at the major lunar standstill when viewed from the north than you can at any other time in the cycle. So if I come back to, I'm just going to put this to terrain. I'm going to come back up to another location here in Colorado. Just find that. So we'll come back to Rocky Mountain National Park. Just search for it. So look, Lone Eagle Peak. That one there. Oh, not that one there. That's better. Right. So you may have seen images of this. Let me see if there are any. Yeah, let's Google it. Lone Eagle Peak. There's a great photo of it. So it's this wonderful pointy mountain. It's probably the pointiest mountain in Colorado, I think. And some images that scrolled off for some reason. There we are. So this is only really viewable. It's most easily viewable from the north. Let's have a look at that. So you can come in here. There's a trail that comes in this way. It's not a hike I've done myself, but you can observe it from sort of here, and you'll see that it's sort of due south. You can see there's the sort of sight line. And if you are in let's go to, let's say, May 15th, 2025, so next year, there's the minimum declination. Oh, that was lucky. That was a lucky guess, I think. And there's the moon. Let's see if we can find the earlier moonrise. It's the moon rising. Need to come slightly later in the night, but the moon, I'm just trying to get it, there's due south, but look how low that moon is, 24.6 degrees. So if I put that on the timeline here, it's so the sight line, I think there's a better example of this, but around that minimum declination, the moon is much lower in the sky than it would be when it's at its maximum declination. It's like you get a big difference. So there's a possibility of juxtaposing the moon against objects viewed to the south at a lower altitude during these major lunar standstills. But it depends where you are. So look at the circumstances and use the declinations as a guide for whether it's going to be high or low. Okay, that's probably plenty on lunar standstills. So ping me any questions you have on that. So let's move on and talk about lunar eclipses. So we'll look at some photographs first off. I'm going to share a different window. I've got a selection of lunar eclipse photographs, and we'll just talk about sort of the key characteristics of lunar eclipses, and then we'll quickly review the tools in the web app for using them. Okay, hopefully you can all see that. Let me make that just a little bit smaller. So let's go through this. So this was, well, let's check when this was. This was May 15th, 2022. And this is the moon rising. This is photographed from Boulder, where we are now. And it's the moon is rising. One of the challenges with lunar eclipse photography is if the skies are bright, this is twilight, you can sort of see the twilight band there a little bit. As the moon is rising, it can be hard to see. So if your lunar eclipse is happening around moonrise or moonset, and those things tend, because it's a full moon, they tend to be pretty close to sunrise or sunset. The skies can be bright, it can be hard to see. So be aware of that. You're looking for clear horizons, clear air as best as possible. As it rises, things become a lot clearer. There's one interesting thing you may be able to make out on this photograph. You see that slight darkening on that part of the of the moon? I think that's the penumbral eclipse. So in a lunar eclipse, we have a number of phases. It starts at what's called P1. P1 is when the moon begins to enter the Earth's penumbra, and the penumbra is where it's the shadow cone of the Earth. It's not the part that's in full shadow, but it's sort of half. Think of it as half shadows. I think in German they call it Halbschatten or something, half shadow. And that's what you see. It's a subtle darkening that you'll start to see on the moon at this point. If you're photographing a full sequence, then you definitely want to take some images before P1. You want to keep shooting through the penumbral phases at different intervals, through partial and through totality. So P1, I think we're past P1 here. The next thing that happens is let's find a good one of the partial phase. We've got a few different shots here. So here, this is back in 2015, this photograph. That's now, so that little darkening there, I think, is penumbra. This darkening here is the full umbra. So you get what's called U1, which is the first umbral contact, where the moon is starting to fall under the full shadow of the Earth, and you get this significant darkening. But the rest of the moon is pretty bright. Here's later during the partial phase, very bright, significantly dark. Just looking at some of these exposures here, you can see, I think, some of the exposure information there. It's 15th of a second f8 ISO 100 for that shot. This one here is a 1/5 of a second f20. What was I doing? I don't know what I was doing there. That's not an aperture you want to be shooting with. But you get a sense of the exposure. And then we get into totality. So let's look at this little sequence here. This wasn't done in May 2024. Let me find out when this was done. This is one of the images from that shoot. So this was May 15, 2022, just going into totality. So there's the little last glimpse of the partially eclipsed moon. So one of the things to take away from this is you get this extreme contrast between when you go into totality of a lunar eclipse versus when you're in the partial phase. It's much more pronounced than it is, say, between penumbral and partial. And one thing that makes it tricky to do is to deal with contrast. You have a lot of contrast in this image. So this is a 20th of a second f6 5.6, which I think is as wide open as this lens would go, and up at ISO 3200, which is less than ideal from a noise perspective, particularly on this older DSLR. But it sort of works, and from that I was able to put together this sequence, and you can see that unlike solar eclipses, in a lunar eclipse, you have less pronounced differences between the phases. So let's just recap: P1 start of penumbral, U1 start of partial, U2 start of total, U3 end of total, U4 end of partial, P2 end of penumbral. That's the whole thing over. So these are sort of the analogs of your C1, C2, C3, C4 that we had for the solar eclipse. But whereas the solar eclipse timings you'll see quoted to 10th of a second, and it matters because, as hopefully many of you saw in last month's eclipse, the difference between the sun being fully eclipsed, totally eclipsed or not, is blinding light. It's much less the case in a lunar eclipse. So timings, you get precise timings for them, but they are of less significance because you get quite a lot of residual brightness, even though we might be officially in totality here. There's still quite a lot of brightness on the limb here. We've got these three central images where things are at their darkest. And then we hit the brightening coming back, and then we're back into partial again. But one thing from a photographic perspective, I think that is very well worth thinking of for your lunar eclipse photography is to acquire focus on the moon before you go into totality. Depending on the magnitude of the eclipse, the magnitude is similar to the magnitude of the solar eclipses, where it's the ratio of the diameter of the solar eclipses, of the ratio of the diameter of the, which way around is this, the moon or the sun that's covered. So if it's greater than 1, then more than the full width of the sun is obscured. And you get a magnitude for lunar eclipses as well. And the bigger the magnitude, the darker it's likely to be during the middle of the totality period. And if you lose focus on that object at that time, it can be quite hard to reacquire it. Certainly using autofocus, you may be able to do it manually. I find focusing on dark objects in the dark using manual difficult, I have to say. Maybe some of you have the same experience. And so one thing that I talked about in the countdown to the lunar eclipse, the solar eclipse webinar last month, was setting up your cameras to use back button focus. And it's sort of this nice halfway house between, it's not manual focus, but it's also avoiding, whenever you press the shutter or half press the shutter, most cameras come set up, you half press the shutter, they do their autofocus seek, and they do their metering if you're in an automatic exposure mode of some sort. And if you keep pressing that, and let's say the moon has drifted off the sensor or it's become too dark, it may not require focus again. I had this in a lunar eclipse a couple of years ago. It was very high in the sky. I hadn't done this. I just couldn't get it back on focus. So I didn't get much out of that shoot. It was disappointing. So what I plan to do next time around is to ensure that I'm using back button focus, and that is where on many cameras you can decouple the shutter button will release whether the camera's in focus or not. So obviously that's a danger, because then it's up to you to make sure that things are focused correctly before you press the shutter. The default settings try to protect you from that. But what it means is that you can then set it, you have this AF on button, say on a Nikon. I suspect there are the equivalents on many other cameras too. And it focuses when you press AF on. So you can focus when circumstances are good, when there's more contrast, and then leave it. Don't touch it, and then shoot without refocusing freely, without worrying that pressing the shutter is going to try to reacquire focus. And one other tip on it depends on your camera model, but you may find a lot of modern cameras with these new fancy sensors have the autofocus. They have these multi-layer sensors with autofocus things on mirrorless in particular built into the sensor, but they tend to be built in horizontal lines. This is true on the camera I'm shooting on at the moment, a Z8. If you put the autofocus sensor on the bottom limb of, let's say, the sun or the moon, a filtered sun or the moon here, it's less good at getting the focus, autofocus, than it is if you put it at the 3 and 9 o'clock positions. And that's just to do with the layout and density of the autofocus sensors in the camera. So try that. If you're struggling to get focus, look for a vertical edge rather than a horizontal edge. This may not be true of all cameras, and it's probably less true of DSLRs, which are using a different way to do some of these focus things. But that's some useful tips for that. I saw a question come in. Do we use bracketing for eclipse photographs? Yes, you can do. I think it's less important than it is for the solar eclipse, but as long as you've got plenty of space on your card, you're not having to shoot at high frequency because these are much longer duration of events. They're likely an hour or more. So you have plenty of time to work. You probably have time to really dial in your exposure, but it never really hurts to have additional exposures. So you might want to do, let's say five frames, sort of central exposure, two stops up, two stops down, something like that. And then you can find what's best in post. These things, you get one chance at them. So if you've missed the exposure badly, then it's bracketing can save the day. Another question, do I use a star tracker for lunar photos? No, these are all manually tracked. It's, again, lunar eclipses are a relatively low pressure situation because you have so much time to work with. The only time when they're not low pressure is when you've lost focus and you can't reacquire it. In my experience, that gets stressful and annoying. So manual repositioning is fine. You may find having, let's see if I have it here. I might show you this if you haven't seen one. This is something I got for the solar eclipse, and it's if I can get the top of it. Fill the screen share so you can hopefully see this a little bit better. Right, okay. Do you see that? Let's put, if I put it, there we are. If I put it in front of me, it zoom won't blur it. This is a geared head, and what it allows you to do. Let me move. Right, okay. You can that way. You see that moving as I adjust the knob. So you get these fine adjustment knobs that let you track this thing in all sorts of different axes. Well, 3 different axes. You can move it around on the top there. So this is just your standard plate. Camera sits in there. It has levels if you want. A lot of architectural photographers use these. But if you're looking for a halfway house between, say, a ball head, which can be a little bit hard to control, versus having a star tracker, this could be a good option. It's less technology, no batteries required, and it makes it very easy just to find position, the reposition, retarget using these adjustment knobs. This one's made by a company called Leo Photo, but there are a bunch out there. Manfrotto make a popular one as well. Yeah, just to reiterate that thing I showed you. Yes, a geared head. You can Google for it. I'll try to pull some up and show some examples. The one that I showed you was from a company called Leo Photo, Leofoto. I think they're Chinese. They're not super cheap, but they're not the $1,800 that you would have to pay for an Arca Swiss head. Manfrotto make good ones. I think what's that company begins with B? There's a few of them out there, so check them out. Check the reviews. Some of them seem to be a little bit more robust mechanically than others. Mike asks, why do I use autofocus for these rather than switch to manual focus and not have autofocus issues? Because I find manual focus difficult. I don't always trust Benro. That's it. Thank you, Timothy. That's the other manufacturer. I find manual focus quite difficult with my eyes being what they are. Glasses are coming on and off. It depends on the camera. If autofocus works, I trust it far more than manual focus. Last night, for example, I don't know if some of you had this experience, but trying to photograph that Aurora, And sometimes you go, how is my focus? What can I focus on? All I've got is a very dark horizon, dark skies, no foreground features. The best bet was to focus on the moon, but even putting focus peaking on in those dark conditions, it didn't help at all. You're just getting dots saying, I can see this, I can see that, anything could have been right. But if I focus back on the moon, which was bright enough to do autofocus, and then move away and leave it using this back button focus technique, then that was working really very well. And I think it works very well in lunar eclipse situations as well. A couple more photos to look at. This one you may have seen. This was another composite from 2014. And these are all the total phases of the lunar eclipse, but you see how bright these things get. And you can also see this is this is a composite, but I suspect that it's pulled the exposure from one of the input images. So 1 second f8 ISO 3200. The magnitude of this eclipse is lower, so everything stays brighter. If you compare that with that's quite a bit darker. So yes, there may be some exposure differences that account for that, but it's also very much they differ depending on the magnitude of the eclipse. Then we have some example of setting. This is during, I think, the nautical twilight. So the sun is between 6 and 12 degrees below the horizon. We're looking up here at a ridge line. This is the top of the sort of the flat irons, which are to the west of Boulder here, and the moon is setting. If you're looking at an unobstructed horizon, by the time it gets down there, the skies are going to be much brighter. The contrast will be much less, and it can be difficult to get an impactful photo in those conditions. So that's a little bit of eclipse. I want to show you this one. Alice took this, a fantastic photo. This is down in Denver, in the state capital. This was in 2015, September 2015. Let's look at the exposure again. This was on an old Nikon D200, 1.6 seconds, f7.1 at ISO 1000. Now you can notice a few things. One is this building is, even at the best, significantly brighter than most of the moon. So you have to think about what you're going to try to juxtapose here. Some things work, some things don't. And it's going to change during the course of the eclipse. So this one works, I think, because the brighter limb of the moon here is closest to the brighter part of the building. If you imagine this was a deeper eclipse and it was all this sort of dark color, it's going to be a relatively low impact shot because of this is going to dominate. But this works, I think, because we've got enough contrast and definition there in that limb to set off against the top of the Capitol building. It also sort of plays off against the little light at the top of the structure there. But I pulled out another one. Position is everything. So here we are at in the wrong location. The moon's way up there. We had to walk much closer towards the building to get that set up. This was on an evening where we were really walking around freely. We were accompanied with a couple of other photographers, so there was no sort of preset plan on exactly where to go. So you're exploring, seeing what works. Have a look here. This one, it's starting to work not so well. I think it's getting a little bit small. It's a little bit dim. This was my shot, not as good as Alice's shot. This was 1/4 of a second, f5.6, ISO 1600. So a few ideas there on shooting the eclipses. So let me switch back now to the other screen share. Let's have a look. New share. Find my window. There we are. Okay. Right, here we go. Okay, so let's just have a look at this total eclipse coming up next March. The September one is partial, so it's a little bit less interesting. But here, a quick recap on a few things. In fact, this is an interest. March 2025 is an interesting month astronomically. What have we got going on? We have the very greatest maximum lunar declination. So it's the peak of the major lunar standstill. And you'll see that a couple of weeks later, let's have a look, there's the minimum, minus 28.73. So that's roughly 2 weeks apart. And note, the eclipse is in the middle of that. Now, why is that? Hopefully, you're beginning to get a sense of how the eclipse relates to the declination. If I quickly go back to this diagram, you will think, well, the moon is sort of, doing its uh, phase, the synodic month, so from new moon to new moon. A new moon occurs when the sun and the moon are in alignment with the Earth. A full moon is when the moon is on the opposite side here. Think about an eclipse, though. A solar eclipse can only occur at new moon, and only when the declination is close to, or the inclination is close to zero. It needs to be lined up. Similarly, with a lunar eclipse, it needs to be sort of here. And when you look at the timings of these things, you've got Friday the 7th, maximum declination. A week later, the lunar eclipse. And a week after that, the minimum declination. So that's this cycle of the moon. That's why eclipses are only going to occur. They're not going to occur at the maximum and minimum. They're going to occur at the sort of 0 point. Note we have a partial solar eclipse coming up here as well on the 29th. Talk about that very briefly as well. But let's have a look at the sequence. We've got P1. We've got an hour and 10, hour and 13 minutes, and then the umbral phase starts. We have an hour and 16 minutes, then total phase starts. That lasts for, what is that, 40 odd minutes. The full moon occurs in the middle of that. Great, doesn't really matter. And we have the point, oh, sorry, longer, yeah, an hour and a bit. That's greatest lunar eclipse. So that is when the moon is at its very, very darkest in the middle of this. So let's select that timeline. Let's have a look at the circumstances in a couple of different places. And you will see there's total eclipse, U2 starting and running through to U3. So this should be fairly familiar from the solar eclipse timelines. And you can see that this is happening quite late at night here in Colorado. So it's after midnight on March 14th. And let's just look at what the elevation of the moon is. It's about 50 degrees, so it's pretty high. Might be tricky to juxtapose that against anything too significant. If we come back over to, let's say we were somewhere in Lisbon, for example, random location I'm choosing just to see what's going on. Let's say we're off on the coast somewhere. What have we got? Well, it's a little bit tricky because it's sunrise. The eclipse starts half an hour before sunrise. So this you might just get the start of it, but by the time the sun is up, the moon is still just up. So that's a particular phenomenon. We've come across this slightly by chance called, I think, the selenium, which is because of atmospheric refraction, you can have an eclipsed moon, but the sun still be up. It's quite bizarre, but hard to photograph because you've got a very low contrast situation with bright skies. The sun is blasting away, the moon is setting out over the ocean. But that's an interesting one to look into. So what I would encourage you to do wherever you're going to be for this eclipse next March is look at the timeline. You understand what the phases are. So you've got the partial phase. That will work well. So nautical twilight, 11 degrees above the horizon, partially eclipsed. That'll be great. But look at how they relate to where the sun is going to be. And obviously check moon set. I still show the phases of this eclipse, even though the moon is set. So greatest eclipse is happening when the moon is below the horizon. So you won't see it in this location. So what you get depends on where you are. If we were to come way over to California, what I would expect is that we're earlier in the evening, so it's a little bit more civilized from a getting some sleep perspective, but the sun's pretty high in the sky. What happens if we come over to Big Island here in Hawaii? This could be good. Oh yes, this is looking quite nice. So let's say we drove. Let's say we came up to Kauai up here. You've got a situation here on the coast. The moon. Where are we? We're at total eclipses. At the start of total eclipse. This is lovely, lovely setup here. The moon 23 degrees out to the east over the ocean. And you've got the partial phase starting just after civil twilight has ended. So that will be very easy to photograph, good contrast, 6 degrees. And the penumbral is starting before sunset, so you're not going to really see that, and it's not risen. Moon rises, so at sunset, yeah. So yeah, that would be a fantastic setup for this eclipse. So the process, I think, for thinking about it is really look at the timeline, look at the key events, look at the altitudes, and check the directions. All the things you would normally do in planning a photograph with photo ephemeris. And then think about how you're going to manage contrast, how you're going to manage focus. And then what you can also do, if you want to photograph the full sequence of the eclipse, let's say, and put together a composite where you recreate the path of the moon through the sky. I haven't done that. It's a ton of work, I think. So good on you if you've got the patience for doing it. But if you want to do that, then you would check, for example, from the moment of moonrise, it's starting at 86.5 degrees. The penumbral finishes over here at 145 degrees. So that's telling you you need sort of 60 degrees of horizontal field of view plus a margin, so 70-ish degrees. So you're going to be needing to shoot it with a fairly wide angle lens. We have a tool to help with that, photoephemeris.com, field of view tool. And in here you can choose your camera format. It'll give you the amount of coverage you've got in terms of azimuth and altitude for different focal length lenses. So you say, well, maybe at 24 degrees, I've got 73 degrees of width on a full frame sensor, which would work. So that's photoephemeris.com/tool/field of view. That's there for you to use for your judge. Yeah, and you would do the similar thing with the altitude. We're going from essentially 0 at moonrise to 65 degrees up by the end of the penumbral eclipse. So here you go, that's going to be a challenge because we don't have enough vertical field of view to capture that. So it could be that we need to go to a wider, let's say we're at 20 even. Yeah, you sort of pretty wide, 15, 14, ultra wide angle lens to get the whole thing in one frame. Yeah, so there we go. Let's have a look for some Q&A. I think we've done quite a lot of talking. I'm going to show you one more thing before I close. And that was, I said I would talk about the solar eclipse. We've had a lot of solar eclipses of late, so I don't want to dwell on that. There is an annular eclipse in October, but you have to travel quite a long way to see it. Where are we? 2024 view. Just look at the path of this. Yeah, you can either go to Easter Island, or you can go to this swathe of South America. It's an annular solar eclipse. So that's in October. I don't think I'm going to be going to see that one, sadly. It's a little bit too much for the travel budget. The next eclipse after that is in March 2025. I view that one. It's a partial only, so it's only showing the partial lines. But if you're in North America, let me show you one little trick that might be worth doing. If you come here, this is March 29th, so that's this magical month of astronomical extremes in next year. There we go. We got lunar eclipse, major lunar standstill at its peak. We've got the equinox. We've got a partial solar eclipse. If you're on the east coast of the US, let's say you went to Portland, somewhere like that. Let's just look at, oops, sorry, clicked somewhere the wrong thing. The sunrise. Let's just look at the simulator and we'll play that forward. You're getting a partially eclipsed sun, partially eclipsed rising sun, which can be spectacular. If I come, let's put this into that's a pretty easier way to see it. So that's available. That's a short opportunity on this sort of eastern seaboard. The further north you go, the deeper the eclipse is. So it's not super deep, but sunrise looking out over the ocean could be a nice one. So those yeah, lots coming up, lots happening. Let me just check in questions. I just bought a Sony 100-400 f4.5 to 5.6. Any suggestions on an f-stop to use wide open at 400 is f5.6. So I don't have any experience with that particular lens, Bob, or with Sony cameras, but I think the general principles are likely to apply. I have the Nikon equivalent of that lens, and I think in a lot of tests you'll find that most lenses, if you shoot them wide open, they're not at their peak sharpness, and so if you stop them down even to 6.3 f8, f8 tends to be a pretty good aperture to use for maximizing sharpness from almost any lens. I don't recall ever reading a review of a lens that says the sharpness declines at these other at f8. So that's probably a good bet. I would check on the forums, see what reviews are saying. There's a lot of good camera reviewers on YouTube nowadays. So I would don't watch just one though. Pick two or three and just get a spread of opinion on these things. People test them in different scenarios and in different ways. So hopefully that will help you. But yeah, I bet that's a nice lens. So I hope you enjoy using it. I also got a 1.4 teleconverter for the 100-400 that I used for the Eclipse. Worked really well with the teleconverter, and at full extension, it puts you at f8 anyway. One thing I have to get clear on my head is f8 with a teleconverter the same as f8 without the teleconverter in terms of what the lens is doing? I don't think it can be, but I haven't quite worked that out. So that's a little homework I have for lens purchases. Well, I think that's everything for today. We covered a ton of ground. I wish I could have made it a little bit more concise, and I hope I didn't lose too many of you with all of the declination numbers. But have a look for these. We're going into the solar maximum, extreme northerly and southerly moon alignments. That's what your opportunity is in the coming months. And you can use photo ephemeris, and you can use the events, you can use visual search to look at when these declination events are in proximity to the sort of moon that you want, either for moonrise or for overhead, or for juxtapositions to the south. I think that's it. I'll put links in with the video. There's a few things that I've looked at here, and I'll share those with you. But that's it. Yeah. So thank you. Thanks for joining. Nice to see you all again, and we'll probably have another webinar in sometime in June, I would think. If you have any ideas, things you'd like me to cover, please write in and let me know. Thanks again. Bye-bye.